everyone, and welcome to E2E Network's webinar on Authenticate, Connect, Prompt, GenAI, the Visual Way by Rosaria Silipo from KNIME. I'm Prajwal and I'll be your host for today. This webinar is brought to you by E2E Networks, a mighty empaneled first hyperscaler from India. Let me now take a moment to introduce to our speaker for today, Rosaria Silipo. Rosaria Silipo, PhD, now VP of Data Science Evangelism at KNIME, has spent 25 plus years in applied AI, predictive analytics, and machine learning at Siemens, Vesica, Nuance, Communications, Private Consulting, and now KNIME, sharing her practical experience in a broad range of industries and deployments, including IoT, customer intelligence, financial services, social media, and cybersecurity. Rosaria has authored 50 plus technical publications, including her recent books, Guide to Intelligent Data Science and Codeless Deep Learning with KNIME. Now on to the main event. Over to you, Rosaria.
So today, thank you for inviting me. So today I'm going to talk about GenAI. Everybody's talking about GenAI, but besides going there to their website and inserting a prompt and getting an answer, how can I build an AI-based application that includes the GenAI prompt and answer within my whole calculation, visualization, model training, whatever it is, data engineering workflow. So I'm going to talk about how to integrate GenAI within an AI-based application. Now, it seems complicated because it seems that you need to code, but actually you don't. So as Prajwal said before, I work for KNIME. So KNIME produces this open source software for data analytics. And the nice thing of KNIME Analytics platform is that it's based on visual programming. So instead of coding, you can do everything with blocks without coding. So today I'm going to show you how you can integrate GenAI in a low code, no code application. Prajwal already introduced me, but if you want to know who I am, just to show you that I'm not just the last one who graduated yesterday. So I work as a data science evangelist at KNIME. I've been working in the data science space for more than 25 years. So I've seen all the innovations. GenAI is the latest innovation. I worked as a data scientist, as a data engineer, and as a data analyst. So I have a bit of a wide spectrum of expertise, and I worked in a bunch of different sectors. So Prajwal already said that. And currently, I'm working on developing use cases with GenAI, because GenAI is cool and everything, but what can you do with that it actually makes sense? If you want, I'm not going to discuss that today. So today is just a little tutorial on how to do this GenAI the visual way. But if you want, at the end, we can also talk about the problems where it makes sense to solve them with GenAI and the problems where it doesn't make much sense to solve them with GenAI and why. But that's another topic. So the goal of this workshop, as I said, it's just a tutorial. So what I did, I had an old fraud detection application. I used it on invoice frauds. Invoice frauds is very common, especially for tax evasion. So I had an old fraud detection application, and then I thought, can I use GenAI for this fraud detection application? The fraud detection application is not too complicated, actually, but maybe I can simplify it and make it much easier, especially to maintain for me using GenAI. So I rescued this old fraud detection application and I inserted some GenAI pieces in there. So we will learn about this fraud detection application. We will learn about GenAI and large language models, and we will learn how to insert it within a bigger application. All of that without any coding. So this is the agenda for today. I'm going to introduce this use case. I've simplified it a bit because it's a tutorial, and of course, if I explain all the tiny little details, it becomes a bit too long. So I simplified a bit the use case. But the use case will be about fraud detection on investment contracts. So I have a bunch of contracts, and some of them are fake. So I need to check which ones they are the fake ones. After that, I'm going to give a short introduction to KNIME Analytics platform, which is the tool that allows me to build the data science applications without any coding. I'm going to talk about the AI extension for KNIME Analytics platform, and then we are going to build this small part of the application, which is the prompting of the GenAI and getting an answer. At the end, I'm also going to talk about how to implement the retrieval-augmented generation process, because as you know, large language models are prone to hallucinations and all this stuff. Anyway, I will explain that later. So let's start with the use case. In the use case, as I said, it was an old application of mine where I was performing fraud detection on invoices. Of course, I couldn't use the data set that I used at that time because, you know, privacy stuff. So I changed the data set. I made my own fake data set with investment contracts. Okay. So what happens? What is the process? I sign a contract, then the contract somehow ends up with the bank or with the cybercrime unit of the company, and the cybercrime unit checks if the contract that arrived with them, it's a legitimate contract or it's a fake contract, for example, for tax evasion. If they find a fraud, then they are supposed to send a warning email to the customer saying, you know, we found this contract, might not be legitimate, either it's a fraud or you have done something that is a bit, you know, gray zone. And usually, you know, a bank or whoever, so whatever company is, has many customers. And each customer, they have a preferred language. So they're supposed to send the warning email in the customer selected language. And that's where the problem actually is. Okay, so first of all, what is fraud? It seems easy to understand, but we have to understand that what the machine understands as fraud is not what we mean as fraud. So fraud, according to Investopedia, is an intentionally deceptive action designed to provide some kind of gain or to deny some kind of right unlawfully. The key here is deceptive. So there is a moral connotation in this intentional deceptive action. So the machine, of course, cannot understand that, cannot understand the moral connotation and the intention behind something, some data, right? The machine can only understand if it's strange or if it's not strange, but it could be a mistake, it could be something else. I mean, between fraud and what the machine sees, there is this moral connotation that the machine cannot understand. Fraud is very common. Don't think that it's a small problem. It's a huge problem. And it impacts people, it impacts industries, entities, legal entities, services, the environment. I mean, there are tons of frauds around. The most common types of financial frauds include tax frauds, for example, this fake invoice problem for tax evasion. Credit card fraud, of course, that's another one that is very common. Securities fraud, like cyber attacks. Insurance fraud is another one, and bankruptcy fraud. Those are the most common types of financial frauds, but there are many, many more. I would like to underline that there are two types of frauds usually in terms of money. There is the fraud that is rare, but with a lot of money. So, for example, your credit card transaction, somebody uses your credit card unlawfully, buys, I don't know, a sofa, and it's a lot of money, which is definitely much more than you would usually spend. But on the other side, there are also this type of frauds that include tiny, frequent amount of money. So, for example, they charge $1 every month, and then you realize that the $1, you don't know what it is, but you don't care because it's only $1. But then if you think that they do it every month for a lot of people, at the end, it has a big impact on society, even though for that month you don't notice. And actually, those are quite frequent, these $1 type of frauds. Anyway, so let's see the problem that I want to use for this tutorial. We have a data set with 100 contracts. Those are PDF file contracts, and they are all set up in some kind of, standard template. So there is this template. They say more or less the same things in legalese, and the only thing that changes is the serial number of the contract, the amount of money, the date, and the demographic of the two people signing the contract. So usually those are the fields that we want to concentrate when we want to discover if the contract is legal, the invoice, the contract is legal or not. If the serial number doesn't follow the template that has been set up, if the amount is strange, either too small or too big, if the date doesn't make sense because, for example, it was on a Sunday and it was closed, and if the person in the contract doesn't exist or the address doesn't exist or something is fishy with this particular person. So we want to find among these 100 contracts, those contracts that find suspicious. Now, as I said, that there is a difference between what we perceive as fraud and what the machine perceives as fraud, because the machine doesn't have this moral connotation. So for machine, we are talking about outliers. We don't want to detect frauds, we want to detect outliers. For the machine, is as best as it can go, as much as fraud detection. In statistics, an outlier is a data point which is different, very different, significantly different from the majority of the observations. So, for example, we have this data set, right? So this is a visual representation of the data set on 2 dimensions. And you can see that there are areas that are densely populated. So these areas that are densely populated represent areas where the majority of something, of people, of data lies, happens. We have also an outlier here. Here is the outlier. So the outlier is something that is significantly distant from all the other areas that are densely populated in the data set, all the other areas that contains observations that are kind of the average, kind of common in the data set. Okay, so outlier techniques are what they are used for fraud detection. Okay, so I'm not going to talk much about the techniques for outlier detection because it's not part of this tutorial. So I've simplified it as much as possible because otherwise it would take too long time. But I'm going just to spend a few slides on that. There are many techniques for outlier detection. The easiest one is visualization, like the one that I showed you before. You visualize your data, and somehow you see that there is a data point or 2 or 3 that are outside of the majority. If it's an histogram, it's going to be in the very, very far queue of the histogram. If it's a bar chart, it's going to be all bars are going to be very small, very high, for example, and the outliers are going to be the opposite, very high or very small. And so on. So the visualizations basically visualizes all the data, and you find those data points that are a bit distant, different from the rest. Other techniques, so the visualization, of course, is nice because you see it, you recognize it, but then it's not automated. So if you want to go for an automated technique for outlier detection, then you need to go with statistics or with clustering or with machine learning. So in clustering, for example, you can use the DBScan clustering algorithm. The DBScan algorithm has this nice property that since it collects data points by chaining them, by proximity, then it has this concept of noise that are all those points that cannot be chained to any of the existing clusters. So it automatically defines the outliers as noise. Another technique in machine learning, for example, is the isolation forest. Or if you want to use deep learning, you could use a neural autoencoder. I can talk about those later if you want. But yeah, so those are the many different techniques. And these ones are to deal with numeric data. So this would be for the amount of money, or if you have some other numeric data in your contract. If you want to, for example, check if a person really exists, then of course you have to do something more complicated. First of all, if the person doesn't exist, you need to check if it's not a typo. Then you have to go for the string similarity matrix and check how distant the name or the serial number of the contract is from a real serial number or from a real person. And then from there, you need to start some kind of check. But today I'm not going to talk about the nominal data. I'm just going to talk about the numeric data because, as I said, I want to simplify it a bit. And I'm going to talk about a one outlier detection technique, which is based on statistics. So the fraud detection process starts like that. First, then we need to read the contract data. Then we need some kind of a technique that tells us, is this an outlier? Is not an outlier? And then if it is an outlier, we need to create an email and send the email, the warning email, the alert email to the customer in his language. Okay. I mean, I could also use as a outlier detection technique GenAI. Also about that, if you want, we can talk. I did use it. It didn't work very well, but if you want, we can talk about that later. What worked very well is the using GenAI to generate the text of the email. GenAI was born from the natural language processing field, so it works very well for text generation in whatever language. So actually, it would be perfect for the generation of the warning email, and that's what I've used it for successfully. Now, I said I'm going to do all of that without coding. To do all of that without coding, I'm going to use KNIME Analytics Platform. KNIME Analytics Platform is a tool for data science. So it covers all your data science needs from A to B, so from data ingestion to data visualization, from data building a data warehouse, to training a machine learning model, from connecting to GenAI, to providing some kind of complex visualization and so on. So all possible data science operations are covered in KNIME Analytics Platform. KNIME Analytics Platform is free, so it's open source, which means it's free. You can go onto the website knime.com, and then you can click on download and then download the software that fits your operating system. Yeah, and then after that, you can just start playing, and then you can start building your data science-based applications. And then the important thing is it's low code. So low code means that you don't need to code. If you want, you can. We have an integration with Python, with Java, with R, with JavaScript. So we have a lot of integrations with actually scripting and coding tools. But if you don't want to, you don't need to. So there are these blocks that you can see here. Each block implements a specific task, and then block after block, you build a pipeline of these blocks, and this pipeline processes your data from A to B, from whatever it is that the beginning until what you want to obtain. So I want to now quickly show you KNIME Analytics Platform really quickly, and then I am going to show you how the GenAI extension, the AI extension works. Yeah, so first of all, as I said, it's based on nodes. These little blocks are called nodes. Each block, each node is dedicated to implement a specific task. In this case, we have this table splitter. Table splitter, as the name says, splits a table. So you get an input data table, and you produce as output two output data table. So this means that each node has one or more input ports to accept data as input, and one or more output ports to produce, to show, to send, to pass the result in data tables to the next node. Now, how does the split happen here? The split happens based on some splitting criterion. For example, all the males on one side, all the females on the other side, all the people younger than 20-year-old, older than 20-year-old, something like that, right? So each node has a configuration window. You double click on the node, the configuration window opens, and then you set all the parameters that might influence, might control the execution of the task of your node. Under each node, you can find this little traffic light. This represents the status of the node. So when you create a node by drag and drop. So there is a repository of nodes on one side. You just drag and drop it into the workflow editor, and then the node is created. But the settings have not been provided, so the node doesn't know what to do. So the traffic light is red, not configured. If you open the configuration window and you set the different settings, for example, if it's a reader node, you need at least the path to the file, minimum. I mean, that's the minimum required. Then in this case, if all the settings are correct, then the traffic light becomes yellow. The node is ready to perform its task. It hasn't done anything yet, though. And then finally, right-click execute. And then if the execution is successful, you get a green light. If there is an error, you get this other yellow light with the cross and the red circle for error. Okay, so as I said, you combine all these nodes one after the other one in a pipeline, you get a workflow, and the workflow implements your data science-based application. In the data science life cycles, there are two parts. The first part is the creation of the application, and that's what we do, what we will do today. So we will create an application, by connecting all these nodes, and then the application does something. Okay, so this is what we have created. But then, of course, we have to deploy it. We have to make it available to the real world outside, working on real data, robust against mistakes or things that cannot be correct in your data set. And then you have to give it an interface so that other people or other tools can use it, can consume it, and maybe interact with it. So you have to monitor it over time. So there is a whole different part of the data science life cycle, which is to monitor, to make the application available to everybody, to deploy it, provide it with a nice UI so that people, they use it easily, and then to monitor and update every time that we realize there is a bug, the data set has changed, the data have changed, and stuff like that. And this is the production part, the deployment part. So one question that I get often about KNIME Analytics platform is, but if it's low code, isn't that like a tool, a toy tool, something like, that I can do a few things with, but I cannot do real applications? So KNIME has this nice feature that is open source. Open source means that we provide a core, and then research institutions, universities, companies, so other groups, they provide extensions for the core software. Providing extension, that means that I don't have only the core part, but I can have also, for example, an image processing extension, a text processing extension, and a GenAI extension. I can have a geolocation extension. So at the end, I have a lot of nodes, and some of them are a bit niche because, for example, we have an extension for cheminformatics. So they might be a bit niche, but that means that a lot of the many of the areas in data science are covered. So in total, we have over 4,000 nodes. But then, of course, the heavy work, the heavy load nodes are only a few hundreds. I mean, this is if you want to go into the DNA analysis, geolocation, geospatial analysis, graph analysis. So all these things that might be not the heavy load usage, everyday usage of the tool. So let me show you how it works. Okay. So this is the UI. These tabs are important, so I will show them later. This part here is the workflow editor. Now here I have already some, I don't remember which workflow was that, but I have already a workflow that I've created before. I would like to show you that if I select a node, let's say this node here, this is a joiner. So a joiner joins two different data sets. So in this frame, under the workflow editor, I see the data set that is resulting from the operation of the node. So here I see the data that I have read from a CSV file. Here I see the data that have been joined from this the CSV file and this other CSV file. So this node monitor is important for debugging, for to check if what you wanted to do is actually what you have implemented, what the node is doing. Another thing that I wanted to show are these 4 tabs here. So let's start with the second one. So the second one here is the node repository. So all the nodes are in this panel here. So I selected the second tab, and all the node repository appears. The node repository contains all those nodes. Now, I said that there are more than 4,000 nodes, providing that I have already installed all the KNIME extensions. But yeah, for sure, those are very, very few nodes. But that's because only the commonly used nodes are shown. And then if your node is not shown, then you either click, for example, show all for the IO category or the manipulation category, and then you have all of them, or you do a search in the search box. For example, if you look for an aggregation node, here, there are all these aggregation nodes. For example, I would use the row aggregator if I wanted to calculate some kind of aggregation. Anyway, I will do an example later. So this one, the third one, is the workspace. So the workspace is a folder on your machine that you can that you use to save, to store all your projects. So here I have many. If you just start, you have only the example workflows here. And then, of course, if you have one selected node here, this is the description tab. So the description tab tells you what the node that you have selected in the workflow editor does, what's the task, and how it does it via the configuration window, here the options, and the ports, the input and the output ports. If nothing is selected, and if you had created a description for your node, for your workflow, which I didn't, so then you would see here a description of what your workflow is doing. Now, briefly, I didn't log in. Okay. So this is the KNIME AI assistant. The KNIME AI assistant allows you to, chit chat with the AI assistant. And if you don't know what to do, for example, you can say, how can I aggregate data? Then the AI assistant is going to suggest you the nodes that perform the data aggregation. Notice that exactly, so the group by node is one of the most powerful nodes for the aggregation. Notice that there are two working modes. One is the Q&A, which is the one that I'm using now, and then the build mode that in theory already introduces the node in your workflow editor. I don't want to ruin my currently open workflow, so I use the Q&A node. And then this last one is the workflow monitor. Basically, if you execute a workflow, you are going to get here the list of errors, if there are any errors, but I'm not going to describe that. Okay, so let's see how I can create a new workflow. So here the three dots, create workflow. I call it demo workflow. Okay, and then I say create. Okay, so then it's empty. The canvas is empty, of course, because I haven't done anything. Then let's go into these example workflows that I have already, and in the data that come with the example workflows. For example, there is this adult.csv file. I drag and drop it. Since it's a CSV file, it creates automatically a CSV reader, and it populates here, double click, it populates the configuration window already with the path of the file, because, well, it knows where it is. Otherwise, I mean, if you want to create your own, you have a file somewhere, you just drag and drop a CSV reader, you open the configuration window, and you write the path here, you look for the file here. There are a number of other options. You can check them. And then here there is a preview so that you can check if what the node is reading is correct. It seems correct, so I say okay. You see the traffic light is now yellow. Now I execute, the traffic light becomes green. You can see here the results, correct, not correct. Here you can write a little comment, like, for example, reading the adult.csv data set, something like that. Yeah, so, and then, for example, if you go back to your node repository, you want to perform an aggregation, you drag and drop the row aggregator, you connect it, then you open the configuration window. Let's say that you want to, for example, where is it? This is for the, okay. So let's say that you want to calculate the average age for men and women. So the average age is the column that you want to work on, and the grouping would be here on sex, for example, right? Right. So you say you want to have an average. Okay, then you run it. then execute, then check here. Female is 37, more or less, year-old average age, and male in this data set is 39-year-old average age. And then one last thing that I wanted to show is that you can write workflow annotation anywhere. For example, you can say this is a workflow for demo, and those are the instructions, and so on. And if you are artistically inclined, you can also make it a bit more, like heading 2, for example, something like that. Okay, and then you can change the color. I don't know, I'm not artistically inclined, so I'm going to skip this part. So anyway, this is how it works. And then, depending on what you want to do, you find the correct node and so on and so on. Okay, so let's go back to the presentation. So the next step is to find this outlier detection. For that, I used one simple technique. It's a statistic-based technique, the interquartile range technique. The box plot, right? The box plot, they are built as these boxes around the median value of the data set for one specific numerical variable. And then the limits of the box, the boundaries of the box are the first quartile, the value for the first quartile, and the value for the third quartile. Okay, so this is a box plot. Now, we can calculate this interval between the third quartile and the first quartile. That's the interquartile range. And then we can define an outlier point, a point that is very far away above the third quartile, and a point that is very, very far away below the first quartile. So defining that with numbers, it means a point that is above the third quartile by a multiple of this interquartile range, or a point that is below the first quartile by a multiple of this interquartile range. So how strict we want to be in defining a point, an outlier or not, depends on the value that we assign to this k. If k is very high, then of course we find less outliers because the distance that I have to cover away from Q3 and Q1 is much bigger. If k is very small, then I find more outliers because the distance that I have to cover to find an outlier is much smaller. Usually k is defined as 1.5, but of course, you can set it whatever you want to become more or less conservative. In frauds, for example, usually it's a bit smaller because then, you might find things that are not outliers, but at least you don't miss the outliers. To implement this technique, this interquartile range technique, we have this numeric outliers node. You just drag and drop it. This is its configuration window. You can see that I work on the payment feature. So each contract has a payment and amount. So I work on this amount feature, on this payment feature, and then I set the value of k 1.5, so the classic. And this, we have another node for the box plot that generates, if you want to visualize where your outlier is. Okay, so again, what I want to do, I want to read the contract data, and then I want to apply this numeric outliers node to find the outliers, and then later we will worry about the email. So this is the workflow so far. I use the PDF parser node to read my contracts. I extract the contract data, especially the payment, the amount of money that was paid. Then in the database, I look for my customer because I want to know the language that the customer wanted his communication in. And then I merge these two values together. So I'm going to have on one side all the data of the contract, and on the other side all the data of our customer. This is a component. A component basically is a node with inside other nodes. If the component contains graphical nodes or widget nodes, then the component will have a composite view that inherits the views, the graphics of the nodes inside. So if I have inside a component, a bar chart and a scatter plot, and then a widget to select, for example, from a menu, the year, then I will have a composite view of the component with a scatter plot and a bar chart and the widget at the top to select the year from a menu. So it's a very powerful visualization feature of KNIME. So after that, I apply this numeric outliers node. I find my outliers depending on K. So I find 2 here, and those are the 2 with the highest, they have very unusual high amount of payments in the contracts. Okay, so now I find these 2 outliers. I have 2 customers to send a warning email to, telling them that a contract was issued in their name for that payment. Okay, so is that really what they had? So at this point, I have to create this email alert. And now we start with the GenAI. Okay, so let's start with a simple prompting of the GenAI. Okay, so again, I have to access the data, I have to detect the fraud. So what I used to do in the past is that I had, I think we had 20 languages. So we had templates for each language. And then we would, the customer chose Russian. So we would rescue the template for Russian. We would insert the fields, the appropriate fields in the template, for example, the contract number, the name of the customer, the amount that we think is fraudulent, and so on. And then we would send the email. Now, this approach, you can do it. Of course, we have done it for years, so it works nicely. The problem is that if you have a lot of languages, you need to maintain these templates. So that means that, let's say you have 100 languages and there is a GDPR coming and you want to add a disclaimer that the legal office wants to add a disclaimer that according to the GDPR, your data will be treated, I don't know, accordingly. Then you have to write this little disclaimer in 100 languages. You have to change the template and add this disclaimer in the right place in 100 templates of languages that you probably don't speak. I don't know how many languages you speak, but usually people, I mean, they reach 5, 6 maximum, so definitely not 100. So you need to ask a consultant, the consultant cost, the consultant has, anyway, the maintenance is complicated. With AI, it's easier because you send a prompt, you say generate an alert email in Russian, and then it generates an alert email in Russian. You can read, so you can check, at least for the languages that you know, if it's correct or not, and then you can trust it for the languages that you don't know. So how do we do that? There are 3 steps: authenticate, connect, prompt. That's the title of the talk. These 3 steps, so they, first of all, you need to have an account with one of the AI provider. Could be OpenAI, could be Hugging Face, could be, there are many now. So frankly, I'm not even up to date with the latest. So you have your API key that you got from your profile page when you registered with the AI provider. So you store this API key in this credential configuration node, and then you pass it to this authenticator node. The authenticator node authenticates you as accredited user with that GenAI provider. Once you have been authenticated, then the AI provider allows you to use a number of large language models, and you just connect, you select the large language model you want to use. They have some, I mean, depends on, the versions, but also some of them are dedicated, for example, for chatting, for embedding, for just general questions, and so on. And then we have the LLM prompter node that, takes a prompt that you have created and pass it to the large language models that it's connected to and produces an answer at the output port. So it's quite easy. At the end, there are only 3 nodes: authenticator, connector, prompter. If we want to use it, for example, with OpenAI, but as I said, there are many other nodes, they are prepackaged to connect to different AI providers. So if you want to use it with OpenAI, then you would use the OpenAI authenticator, then probably the OpenAI LLM connector for a generic large language models, and then probably the LLM prompter because you want to ask just a question. You don't want to build a chat model, but a chatbot, but you want to ask just a question and get the email out, the email text out of the LLM prompter. Of course, the same for all the other AI providers. So at the end, for example, for OpenAI would look something like that. You store the API key in the credentials configuration, then you use the OpenAI authenticator node to authenticate. you select one of the large language models that OpenAI allows you to use, and then you pass the large language model and the prompt that you have crafted in this table creator node to the LLM prompter node, and then you get an answer that you can reuse. So the prompt was write an email in Russian to this customer, name of the customer, with the following requirements. And there were a number of requirements based on the amount, on the payment amount that was in the contract. And this was the email in Russian that the large language model created. So now I don't know how many of you speak Russian, so I have another one which is in English, and it's the same. I mean, same prompt, but instead of writing that in Russian, it's writing in English for a different user. And this is what you can read it. I mean, it's decent. I mean, it makes sense. It's friendly enough, but authoritative enough. I think it was authoritative was among the requirements. And yeah, I mean, makes sense. It's a bit, what is missing a bit is a bit of context. So it looks like, you know, something shows that there was a payment made in your contract. Is that correct? And so on. But it misses a bit which kind of contract was that. It misses a bit of context around the contract that was supposed to be signed. Okay, so I mean, so far it's easy, right? 3 nodes, 1 alert email. But we can talk about GenAI without talking about hallucinations. That's, of course, a classic. So what are hallucinations? Hallucinations is when you send a prompt to the large language model, and the large language model gives you an answer, no matter what. So the answer, you have to trust it. Can be correct, but sometimes it's also not correct. Sometimes it's complete nonsense, and those are actually the easiest to find out because it's so much nonsense that it's easy to realize. But sometimes it's almost correct, and there is a tiny, tiny detail that is not correct. And those are the hardest to find, because if you are not an expert in that particular field, then, I mean, you trust it. It sounds correct. The rest is correct. Why should you, for example, in this case, October 2023 and October 2006, how are you supposed to know that is not correct? So even sometimes people, they use ChatGPT to ask, what to insert in a KNIME workflow, the free ChatGPT, so not the KNIME assistant, AI assistant. And sometimes it puts in there nodes that don't exist. So you need to be, large language models are prone to hallucinations. I mean, this is clear. This is, for example, a spectrum of the common types of AI hallucinations, from the easiest to find out, the complete nonsense, to the most complicated to find out, which has some factual contradiction that if you are not an expert in the field, you will never detect. So there is nothing to do. Large language models are prone to hallucinate. Also, I mean, our email was correct. I mean, it was not wrong, but it missed a bit of context. It missed a bit of description of what the contract was about. So if I receive an email like that, if you sign a contract, I sign tons of contract. Which contract are you referring to? Something like that, right? So a possible mitigation and a possible maybe context addition to the prompt is provided by Retrieval-Augmented Generation process, the RAG process. So the Retrieval-Augmented Generation process is the process of producing a prompt that it contains details and allows the large language model to produce an optimized output. So basically, we want to reference an authoritative knowledge base, which is outside of the training data. So we want to reference an authoritative knowledge base in the prompt before the response is generated. So notice the word authoritative knowledge base. If you don't have an authoritative knowledge base, which is a corpus of documents, of informative documents, then of course RAG cannot be implemented. You need this corpus of documents that you want to use to give context to the large language models. So did we have this context in our case, this authoritative language model? Yeah, we had. So we had the description of the various contract types. I think there were 5 types of contracts. So we had the description of the 5 types of contracts. So I would get an email that says, you signed a contract number, blah, blah, blah. And this contract was about investment fund type 5 that allows you to buy stocks or I don't know what. So something like that. So let's see how the retrieval-augmented generation works. The process is the same. We want to access the data, we want to detect the frauds, we want to prompt the large language model, and then we want to generate email alert. The only thing that changes here is the introduction of this knowledge base in the generation of the text for the email alerts. Okay, so you remember we had 3 nodes, authenticate, connect, and prompt. Okay, now we want to inject the knowledge base as the description of the contract type in the prompt, right? It's not just a simple prompt, it's a more sophisticated prompt, including some knowledge base, as in our case, corresponding to the description of the contract type. Okay, so summarizing, the knowledge base is a set of authoritative documents that can be used for fact-checking, and this helps the large language model to put things in context and also to use a better terminology, right? If I want to talk about healthcare, I have to make sure that I don't use the finance terminology, right? Okay. So how does that work? It works like that. So you take your documents in the knowledge base, you pass them through an embedding model. The embedding model produces a numerical representation of each document, and these numerical representations are stored in some place, which we call the vector store. So the vector store will be a place that contains the set of documents from the knowledge base represented as numerical vectors once they've gone through the embedding model. So the vector store contains all these documents, all these numerical vectors, and the nice property is that numerical vectors are closer if they represent semantically similar documents. So documents that are similar in the knowledge base are going to be mapped to close numerical vectors in the vector store. So at this point, we need a retriever operator that can extract the document that is the most useful for our prompt. So let's suppose, for example, that we have our contract. We want to put in our contract in context by referring to the type of contract that is. So what we are going to do, we are going to pass the contract with all the information into the embedding model, and this contract is going to be mapped to some point in the vector store. Then we are going to look for the closest point in the vector store, and that is going to be the document that describes that contract. So this is how this vector store works. Okay, so then what we need to implement a RAG, we need the knowledge base, but we said we have that. Then we need the embedding model. We need a vector store to store all the documents from the knowledge base. And then we need a retriever operator that finds the closest document from the knowledge base to the prompt that I want to use. And this gives me 3 more nodes. The next, to implement a RAG, I need a node to connect to the embedding model, a node to create the vector store and save the knowledge base in there, and a node to retrieve from the vector store the most similar documents to our prompt, our situation. So this is the knowledge base. Those are all my documents describing my knowledge base, my contract types. Then this is the embedding model that I can connect to still from the AI provider. This is the vector store that I can create and locally save. And this is the retriever operator that extracts the closest description to, for example, the contract that I am analyzing. So Putting everything together, I first provide the API key that I got when I subscribed to the AI provider. Then I get authenticated as a user. Then I select the generic large language model to generate my email. Then I implement the RAG process by connecting to an embedding model, reading the documents for my knowledge base, saving the embedded versions of the document in the vector store, and then finally retrieving the closest document from the vector store, the closest one to the current contract or to the current prompt. At this point, I create a new prompt with all these details coming from the retriever operator, and then I pass this new prompt to the LLM prompter node. So now, what do I get? Here is the original email. You remember, this is what we created without any RAG. This is what we create with the RAG. What is different with respect to what we created without any RAG is this little sentence here that says, as you may know, and introduces a bit of an agreement and a bit of a legal reference and a bit of a description of the contract that supposedly I have signed. This is how to implement GenAI with KNIME. So authenticate, connect, prompt for simple API query. And then connect to the embedding model, vector store, and retrieval agent, retrieval operator to implement the RAG process. And this is the final workflow. So you can see here is the reading part of my contracts. Here is the visualization. This is the numeric outliers for the fraud detection. I could be more complicated, but as I said, this part is not important for this tutorial. And here you can see the generation of the alert email by authenticate, connect, prompt, so simple prompt to the API of the AI provider, or authenticate, connect, prompt integrated with the RAG process, knowledge base, embedding, connector to the embedding model, vector store, and retriever of the closest document in the vector store. And this is the result. So you can check, this is a tutorial, as I said, it's derived from a more complicated case, but it's available on the KNIME Community Hub. The KNIME Community Hub is a space for the KNIME users. If you register, you get 50 gigabytes for free. And then, you can save your work there, or if you want, you can also make it available to the whole community, to share, you reuse it, learn from you, and so on. So this particular exercise is available here, or you can scan it. You can go there, download it, import it, download it, import it, change it, play with it. And then let me know if you need any more help. If you want to learn more about KNIME, there are courses. You can go to this web page and find all possible courses. You can become a data analyst with us, a data engineer, a data scientist. You can be certified, all sorts of levels of proficiency level, but also all sorts of professional profile level. We have cheat sheets, so you don't need to read a whole book to learn about KNIME, where, in the cheat sheets, we have the most commonly used nodes to do something, for example, to do machine learning, to do data wrangling, to do orchestration, and so on. And then we have books. We also have on a KNIME TV channel on YouTube. We have tons of educational videos, panel discussions, podcast. I run a podcast on LinkedIn. The next one is on the 21st of August, where I interview data professionals in the KNIME community. The title is My Data Guest. And that's it.
Heartfelt thank you, Rosaria, for this insightful session, and a big round of applause for all of you who joined us today and participated so actively. Before you leave, we are eager to hear your feedback on today's session. Please take a moment to fill out our quick NPS survey. Your responses are incredibly valuable and will help us improve our future webinars. While you fill the poll, let me give you an introduction to what we do at E2E Networks. E2E Networks Limited is the leading first AI hyperscaler from India, focusing on providing advanced cloud GPU infrastructure. We lead the industry as a prominent cloud GPU provider offering a comprehensive range of NVIDIA GPUs, including the HGX, H100, A100, L40S, L4, A40, V100, and T4S. To know more about us, you can check out our website e2enetworks.com. You can sign up at myaccount.e2enetworks.com. I'll be posting both the links in the chat box for your reference. Thank you, everyone. That's all from us today. E2E Networks. We hope you found this webinar valuable. Stay tuned for more such events from E2E Networks. Have a wonderful day ahead.